In the name of Allah, the most merciful and the more beneficent. Assalamu alaikum. Is Mubashir Ahmad, a final year student of Electrical Engineering Department, Sakkara University, along with my group mate, Mr. Anwar Alirin. Today, I am here to present my FIP topic, that is network connected over and under voltage and our current protection system, under the supervision of Dr. Suresh Kumar, co-supervision Dr. Mohammad Wakas. First of all, contents. In contents, we will discuss in this presentation introduction, motivation, problem statement, aims and objectives, literature review, methodology, results, conclusion, future work, references. Now, in the introduction, high quality electric power supply is the prime goal in the modern power systems around the world. One of the main ways to achieve this is the protection of the system, which need to be fast, reliable, and cost effective. The objective of this project is to provide the protection of equipment in low voltage LV distribution system and thereafter to avoid their failure due to abnormal operating conditions. This proposed device provides protection to the residential equipment appliances by monitoring under an hour voltage and hour current condition using microcontroller ESP32, PT, ZMPT10V, 101B, potential transformer CT, current transformer HCS712, and other discrete components. This complete project is based on two units. One is primary unit and the other is secondary unit. The primary unit will monitor the voltage and current as well as control switch on and off the secondary when anomaly occurred in the system. Secondary unit. This unit connect the load or device with the primary unit. The motivation. The motivation behind this project. This project is about developing an internet or network connected over and under voltage and our current protection system that monitors the behavior of voltage and current of the household loads or appliances and protect them from undesirable conditions of voltage and current that occurs in the residential areas. To disconnect individual load or appliance from main supply with respect to their rated voltage ranges when disturbance occurred in the system. To set voltage and current ranges remotely using Android-based application. Automatic switch on and off through wireless communication between the primary and secondary unit. Problem statement. One of the most important challenging tasks is to disconnect the individual load or appliance from the main supply when the anomaly occurred in the system. Home appliances have different ranges of voltage to operate, therefore, it is another challenging task to cut off the loads according to their specific ranges. The protection of the residential appliances is especially valuable and costly appliances. Aims and objectives. The aim of this project is to design an IoT-based smart system that manage the hour under voltage and hour current protection of the home appliances as well as network connected real-time data acquisition on the server. Objective. There are three basic objectives of this project. Design of a smart circuit that controls switching on and off of the individual appliance. Real-time data acquisition on server, observation of equipment behavior through network, and set the hour under voltage ranges through Android-based application. Now here we have literature review. In literature, we have compared some previous work of authors with our current project. The first paper title name is Development of a Low-Cost Microcontroller Based under an Hour Voltage Protection Device in the year of 2014. In this work, the author is using PIC 16FA77 microcontroller. In the other hand, we are using in our ESP32 to make our system network connected. The second page titled Under Voltage and Hour Voltage Protection of Electrical Appliances. The published date is 2017. In this work, the author is using potentiometer to set the voltage ranges. In our work, we are using Android app to set voltage hour under ranges. The third page, we have studied electrical appliances protection using auto cut, under voltage and over voltage tripping mechanism. The published date is 2020. Here, the author developed auto cut circuit technique by utilizing relay, transistor, operational amplifier, and other components. In our work, we are using individual relay using four switch on and off the load using secondary. The fourth page, we have studied the hour under voltage protection of electrical appliances. The publishing date is 2017. Quadcopter IC is employed with two additional comparator ICs as window comparator. But here we are not using any IC. We are measuring AC voltage and current just using PT and CT with ESP32. We have Here we have represented the work and methodology of different authors working on protection of home appliances from hour and under voltages. The most important key point of our proposed system is to protect the individual device according to its weighted voltage ranges using single primary unit that can control the multiple secondary units. Now we have a methodology. Here you can see that first of all we have an input supply. Then we have a primary unit. The primary unit consists of CTPT, ESP32, and LCD display. Now, the line voltages of secondary one is connected through the primary unit, and similarly for the secondary two, the line voltage is connected through the primary unit. And both secondary one and secondary two are wirelessly connected with the primary unit using the ESP-NOW protocol, and the server and the primary units are connected with two-way communication. Similarly, mobile app and server are connected in two-way communication. The two-way communication means you can send or receive both. You can send and receive data both simultaneously or the same time. Now here we have created an example. For example, the hour under range for the load one or secondary one is 190 to 240, and for secondary two is 180 to 230. Now, if we have a voltage less than 190 that is observed by the primary unit, then it will send the command to the secondary one to switch on and off the load. In this case, the secondary one switch off the load and the secondary two run on a normal condition, and it will turn off the load when any anomaly occurred or the voltage ranges meet of the secondary two ranges, then it will switch off the load. Now methodology. Here we are discussing individual role of the each part of the methodology. First of all, design of a primary unit. Primary unit is basically measuring and controlling unit, consists of ESP32, potential transformer ZMP-T101B, current transformer ACS712, 16 by 2 LCD, and other discrete components. Design of a secondary unit. Secondary unit is consist of ESP32, relay, and CT ACS712. This unit is basically switching unit on and off wirelessly connected with the primary using ESP-NOW protocol. Design of the Android app. The mobile application is designed using MIT App Inventor. This app is designed to observe the behavior of voltage and current as well as to set the hour under voltage ranges. Cloud server. ThinkSpeak server is used to send and receive data. The server we have used is the ThinkSpeak. Now we have some results on a hardware. Now you can see that this blue box is basically a primary box, primary unit. The LCD is on the top of this box is showing the voltage 226.88, and the 100-watt bulb is connected as a load, so it's showing 0.44 ampere flowing from it. Now this is we have secondary unit box. Now this is our also project of the system while testing. Now here we have mobile application result that we have designed for our project. Now this is a home screen page where you can set the voltage ranges, minimum voltage or maximum voltages, maximum current. Similarly for secondary two, here we have designed only one secondary, but we can make more secondary. It can be connected with the primary unit wirelessly. Now this is a numeric data page where you can see the voltage, what voltage is coming on the primary unit and what current is flowing through the primary unit. This is a graphical data page where you can see the graph of the voltage and current. These are the some observation while taking experiment. These results and observations are based on the voltage behavior when the connected load is 100-watt lamp. This proposed system will switch off or disconnect the individual load from main supply according to its rated voltage limits when any anomaly occurs in the system. Now in the figure 1 you can see that the everything is on normal condition. The voltage is 226.88, load 100-watt bulb is connected and is running 0.44. The voltage are observed on the server is 226. Same values and same currents are showing on the server, but in the figure 2, you can see that the voltage are dropped with the help of fan regulator. We vary the voltages and the voltage observed on the primary unit is 151.11. The same values are showing on the server, and the current is showing on the server is 0, as well as on the primary unit the current is 0. It means the voltage are below the set point, therefore it's disconnected the load. Similarly, where we have a graph, as you can see that when the voltage are in normal ranges, the current flowing through the 100-watt bulb is 0.44 approximate. But when the voltage is goes below the set point, the current bill becomes 0. It means the load is switched off. But when the voltage are improved again, the current is flowing through the load, which means the load is switched on again. Now we have a conclusion. We have successfully designed and fabricated a smart IoT-based protection and controlling system with the following features. One can declare the hour and under voltage limit through the designed Android-based mobile application, can automatically switch on and switch off the individual load or appliance according to its weighted r- voltage ranges. Single primary device can be used with more than one secondary unit. One can also control appliances remotely by using internet. Now here we have a demonstration video for our project while taking observation. Thank you. Now we have a future recommendation for this project. This project has the following future recommendation that can be encountered in future. More secondary units can be designed for different load appliances to work on different voltage ranges. Local server can be made for send and receive data. Here we are using ThinkSpeak server. This is a paid server. Here we are using it freely, but there is some time delay while updating the value. So we can use or more beneficial server like Adafruit and many other, or we can make our local server for this project. It's not a hard task or not. It's is easy task. Now more option can be added to Android app, like notification system can be notified when any anomaly occurred in the system. There are few references that we used. Now this is Sakrabi University. Please like us and follow us. Thank you. Thank you so much.